A warm welcome. This is Electric Energy Generation Utilization and Conservation course with lecture 5.5 focusing on power quality aspects in nonlinear and domestic load. We can see what is power quality first. Normally, the power qualities or issues like voltage sag, voltage swell, then short time interruptions, long time interruptions, then harmonics. These are all considered to be certain power quality issues. So, what is meant by power quality? The electricity which is generated has to reach the consumer with the proper way. I mean, how is it generated? With that intents, it has to be supplied to the consumers. But anyway, the transmission line is of long distance, and then we are getting subjected to step down as well as step effect of effect up. And after that, the electricity will be distributed from substations, and finally it is reaching the consumer. So definitely there will be certain power quality issues. So what can we do with this power quality issues? Whether it can be accepted or not? Definitely it cannot be accepted because this will damage the load very specifically. The sensitive loads will be getting highly damaged when such power quality issues prevails. Because if short time interruptions are present for a short period of time, the electricity supply will be absent. In such a cases, many, for example, if it is a motor, then it will stop, and after some time it will be getting into on state, and then it will then to off state, and again to on state. These in these ways, the motor operation or its efficiency will be completely degraded. So what we can use? What is the source of power quality issues actually? Main thing is non-linear loads. We cannot find a linear load in practice. Each and every load is non-linear in nature. So the usage of non-linear loads is also increasing day by day. So a lot of distortions in the current and the waveforms are occurring due to the usage of these non-linear loads. Hence, these power quality disturbances have to be suppressed through either filter circuits or through any other measures. We have to reduce it. So what is the main cause for power quality issue is the harmonic distortions. This is the main thing, and about 60 percentage over the all over the globe, the nonlinear loads are being maximum used. So study of their conditions below serious harmonic contaminated networks can be a better thing for understanding of what is going on, how to treat the electrical load, because usage of nonlinear loads cannot be avoided. I mean, it cannot be avoided. It's a necessity one. It's a basic necessity of life. So we can understand and practice how we have to deal with that, with those electric loads. For this analysis, the harmonics present in the nonlinear loads have to be critically studied. So there are many causes of harmonics in a facility. So what are they? The consequences are, I mean, in distribution systems, the transformer area is where the harmonics will be getting into a core saturation. It will be, I mean, the core saturation can be used for the generation of the harmonics. So harmonics, while considering third order harmonics, is of very high impact, and it creates a lot of disturbances to the original signal. And higher order harmonics that can be easily removed using the filters. So what and all the consequence of the harmonics? Because only the effect can be, it will be experienced first. So what are they? First is extra heating and better insulator stress on the capacitors. Interruption capability of the circuit breakers may get disturbed. The electrical phenomenon of the conductors may vary. The scale back lamp life gets reduced. And the activity errors in instrument like wattmeter and meter, they will not display the correct value. Heating occurs, rhythmic torsion occurs, and noise will be present in the rotating machines. All these indicates the presence of the harmonics. So the value, how the consumers or the users can handle with the harmonic currents in addition to the traditional load and the increase in losses, because already we have certain losses in the machines. In order to accommodate, those losses will be getting increased. They will be backed up when these harmonics are present additionally. So during loading conditions as well as under no load condition, how these harmonics can be um, handled. That is the clear trend now. So now we can see how the degradation of the network voltage occurs due to the nonlinear load. Here just we are going to study what is the impact of harmonics, right? So you can see this is a voltage source which is being provided here. For other loads, it's not a great issue. When you're using a nonlinear load, we can see the harmonics as such. So it is nearly the same as that of the base frequency, right? So the automatically our system or the load will respond to that type of voltage or the frequency, and this will be resulting in the degradation of the total entire network. All these power quality issues can be reduced, that is whether it is an voltage sag or voltage swell or short time interruption or long time interruption or harmonics, they can be reduced with appropriate actions over these individual effects, because totally a single method cannot totally suppress all the power quality issues. Each power quality issue can be handled with several different techniques and can be at least eradicated to a greater extent.